So this is the third-party content talk. Now it's on. This is the third-party content talk. If you want to see any of the others, just look at the one-pager or the schedule and go to whatever talk you're interested in. For the people here, though, there's a big gap right here, which is kind of jarring for speakers. If we could consolidate a little bit, that would be great, specifically this side. If you could move over just a little bit, that'd be really appreciated. People back there, you can't really be seen by the speaker, so if you want to move up a little bit, just to make it feel a little bit more condensed. Otherwise, I'll hand it off to these gentlemen, and I'm going to keep editing the schedule. So.
Hello, am I on? Okay. Hello, everyone. I'm Stefan Zager. This is Ojan Vafai. We are Google engineers working on Blink, and we're here to talk about third-party content. I do want to make one brief digression. I would like to recognize a colleague of ours, a beloved member of the Blink family who has gone on to greater adventures. And I just want to say, fare thee well, Levi Weintraub. We wish you well.
For the record, Stefan did not tell me he was going to do this.
Okay, third-party content. How do we go? Okay, so composition of content from multiple sources is ubiquitous on the web platform today. We see it everywhere. And it is a great strength of the web platform, in my opinion, but it's also a weakness. It's a strength because it allows developers to produce pretty sophisticated web pages, pulling in sources from all over the world with some pretty basic constructs. It also happens to enable a very successful business model on the web. However, it's a weakness because once the page author sort of opens the barn doors and lets the third-party content in, that third-party content really has the ability to degrade the user experience and really sabotage its embedding page. And the author of the embedding page really has very little recourse to do anything about it. I want to go into a couple of examples of how this happens. So here's a DevTools trace. I think that Forbes.com might actually appear in a couple of presentations today, so I think it's just their bad luck to have been mentioned in a tweet recently. But desktop version of Forbes.com, the testing device was a Chromebook Pixel 2, so that probably runs Chrome about as well as anything in that form factor. Page is fully loaded. There's no network requests going on. There's no layout happening, anything like that. It's scrolled down to a point where there are no visible ads, just text. There are no animations running. There's no video. There's no input events from the user, so I'm not doing anything. And what I want to point out is the total time spent running code versus the total time spent idle. So they're close to equal. In fact, that's about 49% of all available cycles are being spent running JavaScript. That's bonkers. If you are on a MacBook, you'd probably hear your fan start to turn on shortly after you started this trace. What this does is it kills your battery. All the complaints about Chrome killing your battery, this is a big part of it. Another example, this is on mobile this time, and for a little local flavor, I picked a German news website, a popular one. This is running on a Nexus 5X. The page is again fully loaded, and I'm just scrolling slowly from top to bottom. And again, it's about a 10-second trace. And what I want to point out is, if you can see them, these numbers for total runtime. Each one of these is an uninterruptible function call. And we have 658 milliseconds, 474 milliseconds. So that's completely blowing frame budgets. So if there's any layout or painting that has to happen at this time, we're going to be janking badly because of this uninterruptible script. You see it's coming from a lot of different sources too, right? This is all third-party code. If you take a look at what event handlers are registered on this page, I have 4 different scroll handlers, Bob. that means that every time there's a scroll event sent to the window, I've got to run 4 different callbacks. Again, pretty bonkers. And to dive just a little bit deeper into how some of this comes together into a bad experience, where do I point this? Okay, so this is an about tracing trace, and the reason I like these is because you get to see everything that's going on, but also these purple and white stripes are vsync boundaries, so these are frames being pumped. So let's walk through it. Over here, something happened that modified layout in a way that's going to require a new frame to be pumped. But before we can generate the new frame, an XHR on load handler runs, so some external resource just finished, and the callback on that runs for about 33 milliseconds. So, okay, we're already a couple of frames behind. So let's hurry up and schedule a new frame to run. So that's begin mainframe. That'll be the next task on the queue that runs is let's generate a frame. First thing that begin mainframe does is process scroll events and run the callback. So what we see happening here is an event dispatch calling into a V8 function. So this is one of those scroll handlers running for 36 milliseconds. Okay, so that's another 2 or 3 frames gone by. By the time that all of this gets done and we actually generate a frame and send it to the GPU, it's 6 or 7 frames behind. So any one of these 2 in isolation might have caused us to miss 2 or 3 frames, but when you stack it together like this, you miss 6 or 7 frames, and that goes from being, sort of maybe barely perceptible to being very noticeable by the user when you miss 7 frames. And this is just, and I would like to say, I did not pick a particularly egregious example here. I was really trying to be representative. It's really easy to find stuff like this when you start digging into traces. This site, site.de, is not a particularly bad site, but this happens all the time, and it's just poor coordination between different sources of script. It's not uncommon if you look into this trace to see 5 JavaScript timers or more firing during a single frame execution, right? So we've been beating the drum about Rail for a couple of years now, but the truth is when you have a lot of third-party content in your page, it's pretty hard to hit that rail, when you have all of these things working against you. Okay, so we have a problem. What do we do? Lots of ideas for how to address this, but we've broken them down basically into 3. One is new web-facing APIs that will hopefully allow developers to get away from some of the Rail busting idioms that are common out there today. And I think of this as like the carrot. This is like we're actually trying to do something nice to developers and make them love us more. There are also Blink internal implementation changes. For example, all of the things that they're doing to make V8 faster and smaller and run quieter. But these are changes that have no developer-facing changes. It's not a change in the web platform. And then finally, there's the big guns, the scary interventions, user agent interventions, which basically means a change to Blink which deliberately breaks the web platform in the interest of improving the end user experience. So I'm going to talk just a little bit more about one example of a new API that we think has great potential to, again, to break some of these habits in third-party content. And then I'm going to turn it over to Ojan, who's going to play bad cop and talk about all the scary things that we want to do to break the web platform. Okay, intersection observer. A big problem, or I should say a big functionality we see over and over on the web is how to tell if a particular element is on screen. Obviously, ad impressions is a pretty obvious use case. There's also things like infinite scroll, where you want to, say, populate a list that has some padding past the end of the visible page, but you don't want to create too much DOM. So what you do is you wait until the user scrolls up a bit, and once you run out of some runway, you want to populate some more content at the bottom so that there's an uninterrupted infinite scroll. Or lazy load of external resources. Maybe you will want to use the same kind of mechanism to determine when you need more content from the web. So the state of the art for doing these things is pretty gruesome. On desktop, it is pretty common to see, especially third-party content, instantiating 1 pixel by 1 pixel flash elements. And they'll place the flash element right on top of the element that they're interested in the visibility of. And the reason they do this is Flash will throttle back the frame rate of a flash element when it is off screen. So they create this 1 pixel flash element, and then they just measure frame rate. And that's how they know if their thing is on screen. Yeah, right, yeah, okay. Can I just acknowledge that that's bonkers doesn't do it justice.
Well, and to add a little color to that, this only tells you 1 pixel. So if you want to know like how much of an ad is visible, you might have like 12 of these flash pixels for a single ad.
And also, because there's some interest in, maybe this is too controversial to talk about, but interest in reducing the amount of flash content on the web, we have discovered that these very small flash elements constitute a very large share of remaining flash content on the web. Okay, so when you're on mobile, you don't have flash available, so pages generally use some combination of polling, using set timeout or set interval, and scroll event handlers, like the ones we've seen. Pretty common practice to poll at a 100 millisecond interval to measure visibility of ads. So when a page is completely static, like that Forbes.com page, we're still running 10 callbacks a second to determine if an ad is visible. Okay, so the solution is a new web-facing API which runs a JavaScript callback whenever the state of intersection between a parent and a descendant element changes. So I think the canonical way to think about this is a scrolling container, which is the parent, and something inside it which is maybe below the clip. But as you scroll up and it just comes into view in the visual viewport of the scrolling container, we would run a callback to notify the code that this has happened. And again, if an element goes back off screen or scrolls off the top, we would run the callback again. The code is really very simple. One thing I particularly like about it, and it's yet to be seen how this actually works in the wild, but although the measurements of intersection are very accurate because the measurements are done at frame generation time, so it's very, it has a lot of fidelity to what's actually displayed on the screen. The notification, so when the callback runs, is actually done using an idle callback. So it's using the same machinery that we use for request idle callback, which is an API that shipped last year, which basically means browser, here's a callback that I would like you to run whenever it's convenient. So, not when you're scrambling to get a frame out or have other important stuff to run, but whenever you have some idle time. So because things like ad impressions, you're not using this to drive layout, you're just measuring visibility. As long as you're getting accurate timestamps, if the delivery of that information is delayed by 100 milliseconds, you still get a very accurate ad impression. So our first implementation of this shipped in M52s, which means it's sort of just hitting stable. There's been a lot of interest from from third-party developers. So we're optimistic that this is going to make a big dent. And just to sort of drive that point home, I want to go back to this page. So Kenji, who's here, and I would like to give credit to Kenji for doing a lot of the original analysis. A lot of these slides are just plainly derived from his previous presentations on this topic. And Kenji, I understand, did a deep dive into Forbes.com specifically and found that of all this script that's running, the great majority of it is calculating the visibility of ads. So we have reason to think that Intersection Observer can make a big dent in this problem. So again, version 1 just shipped. It measures intersections and it calculates CSS clipping and also overflow clipping. We have an idea for a V2. So the idea for V2 really came out of discussions with third-party developers where they told us other things that they would like to do to help them. And in version 2, we would like to try and detect paint occlusions. So that would be detecting not just the position of boxes, but what's painted on top of an element or underneath, whether there are filters applied, whether there's an overlay, whether it has drop shadow or transform. So it's really early days. We're still just, sort of spitballing this. But we think that this may have the potential to make a really big dent in ad fraud detection as well as clickjack prevention, because it suddenly becomes possible to tell whether your PayPal badge, which is going to give somebody some money, was obscured at the time that it was clicked. We are at the stage now where we think we have an idea for how to do this in Blink in a performant way that's not going to kill performance, and we're going to hopefully be doing a proof of concept later this year. Maybe we'll have something to report at the next BlinkOn. And now I'm going to hand it over to Ojan.
All right, so I'm now going to talk about the crazy bits, or as Dimitri apparently called it earlier, OMG emoji. Feel free to pay more attention to the emoji than what I'm saying. So what are interventions? Whoop, wrong way. Interventions basically consist of two required attributes. Stefan mentioned them earlier. One is you're breaking some long-standing web behavior. The other one is that it benefits the user directly. Historically on Blink, we have removed a lot of APIs in the past where we were like, the usage is low, we want to simplify the platform, that'll make it better for us, it'll make it better for developers. But the user benefit was through this level of indirection of we'll make the platform better, and then users will benefit because developers will make better sites. That's not true for interventions. For interventions, if you describe the intervention to basically any user, and you describe the benefit that they'll get out of it, they'll be like, oh my God, I want that. And we'll talk through some examples, and you'll see sort of what I mean. A lot of interventions have an opt-out. Whenever we can, we like to give an opt-out. It's being developer friendly. There's some cases where it doesn't make sense or it just isn't necessary. And then very rarely, only when we really have to, some interventions only apply to some pages. So for example, we have some that only apply if you're on a very slow connection. So funny story is Dimitri actually coined this term. And he did it he was writing this document to, he was seeing us doing these sorts of things where we were breaking the web, we were making developers really sad, and then through ecosystem changes, we ended up making users sad too. And he was like, we should stop doing this. So he sat down to write a document about why we should stop doing this. And over the course of writing the document, he was like, wait, maybe there's a good way to do this. And that is basically rational interventions. So breaking the web is easy, and you can get sort of a short-term user benefit, but then you break the ecosystem and you make the user benefit goes away. So rational interventions are break the web, but keep the platform sane. And bonus points, sometimes you can actually change the web, make the platform more sane. You do break a small amount of content, but if you were designing the platform from scratch, you'd be like, yeah, that's of course how it should work. And those are interventions that we especially like. So it's a spectrum. Very few things fall at either extreme of the spectrum, but we try to get as far towards the rational end as possible. Up to now, we've sort of been talking a lot about performance. It's actually not just about performance, and in fact, most of the interventions we work on are more about user annoyance than they are about performance. No. How do I do this? Help. I don't know where the slides are. There's a video on the slide.
Yeah, this one?
Oh, it's playing. Ah. Thank you. All right, so this is an example. A random person on YouTube uploaded this. This is coincidentally, we didn't make this. And all of you can see this and be like, I have had this experience. It's super annoying. It gets better. Can we go back to the slides? So yeah, this is one of those things, right? You show any user this, and they'll be like, yes, I don't like that. Please don't let web pages do that. And how do we get out of that? That is the gist of interventions, right? Is if we can fix that problem, users immediately benefit. There's no, like, eventually developers will start using this new thing, and then over time. It's like the benefit is pretty palpable. So how do interventions happen? Basically, the cycle is, we'll find something like that and be like, yeah, that's super annoying. That happens all the time. How do we fix it? We'll brainstorm really crazy ideas that are really terrible. And then we'll think a little bit harder and be like, yeah, but that's like obviously not going to work. It'll break too much content. Or if we do that, developers will do this, and then we're just back in the same place. So we think some more, and then we sort of arrive at sort of semi-rational interventions. And at that point, we're like, OK, we have something we can at least talk to other people about. We'll start talking to other browser vendors. We present it at the incubator community group at the W3C. It's a location we can talk to other browser vendors about this. And then in the end, we arrive at something that is mostly a rational intervention. Hopefully, it's like a purely rational intervention. And then we basically just go through the regular spec process. You write this, you modify the appropriate spec, you send in intent to implement, you ship it. So I'm going to walk through a few examples of interventions we've considered, and sort of you can see the irrational to rational spectrum. This was my crazy idea of the week, last week. I went to a news website, and I was looking at it in the DevTools, and it loaded 110 different domains on page load. That's never going to work well. I'm not trying to shame here, so I'm not telling you which news website, but you've all used it, I'll tell you that much. And this isn't even that uncommon. And like I was like, all right, let's dedupe by subdomain, because there's subdomain hashing. And then it's still 70 different domains. And to own it up, 12 of them were Google domains. So I had this thought. There's no use case for loading that many different domains in such a short amount of time. What if we rate limit the amount of domains you can hit per minute, let's say? It's like kind of not that different than the way we limit the number of HTTP connections you can have. Or the, what's this called? The number of domains you can hit. The connections per domain, thank you. And then the other problem is, but then you could like create an iframe, and in that iframe you can do a bunch of extra domains. And in the ad world in particular, part of the difficulty is the top level ad network doesn't actually just load an ad. They'll oftentimes load another ad network, which will then load another ad network. And this is all done client-side with nested iframes. And each of those nested iframes can load a bunch of other domains. And this is part of the problem. The news website is only doing like half of those 100 domains. The other 50 are from nested iframes. So I was like, OK, we can limit each level of nesting, how many domains you can load. That's a little crazy. It doesn't quite fit. It's probably too draconian. It probably breaks some legitimate content. The user benefit isn't that obvious. Like it's sort of like, you can see how it might push the ecosystem towards better web pages, but it's not immediately palpable. So that's more on the irrational end of the spectrum. Also on the irrational end of the spectrum is something that Chrome and Safari both shipped a couple years ago, which is on mobile, we required the user to actually tap on the page in order for video to play. And that seemed kind of nice. It's like, well, yeah, that's a great user experience. You don't want to be using your phone in a talk, and you navigate to a web page, and it starts playing a video. That's super embarrassing. And so the user benefit there is clear. But we didn't really think through the ecosystem impact. What's happened now is it's quite common, actually, for people to decode their video in JavaScript on mobile, which is strictly slower. And it's basically just a strictly worse user experience. Good news is, as of this week, I guess, Safari and Chrome are both changing this behavior. We're going to allow video that's muted to play. We're not quite satisfied with that. We think that's still too draconian. Like sites like Twitch and YouTube and Vimeo, when you go to those sites, you do actually want the video to play. It's actually a worse user experience to require you to tap. So we're not going to stop there, but at least we've mitigated some of the negative impact of this. But this sort of gives a flavor for why we care so much about the ecosystem, is if you get this wrong, you haven't actually helped the user. You've made it worse. You fix things for like 6 months, but then things actually just get worse in a couple of years. So the video we watched earlier, here are our current thoughts on how to fix it. There were two things, right? There was the accidentally clicking on a thing that just pops in. And so our solution for that is number 2 here, which is we're going to focus specifically on cross-origin domains, cross-origin frames. So cross-origin frame that has moved in the last, say, 500 milliseconds, we're still working this out. If you click on it, then you almost certainly were not aiming for that if it just popped under your finger. And we're just going to pretend you didn't click on it. No click event. It's not backwards compatible, but we think it's probably good enough. Part of the reason we're focusing on cross-origin frames is there are like legitimate use cases. If you're building a game, for example, that is going to ruin your user experience. But if you're using a cross-origin frame, it's probably OK. The things people use cross-origin frames for are mostly advertisements, videos, that sort of thing. Oh, sorry, I left out the other one. The other one is how do we deal with the back history thing? Part of the problem there was the page was just navigating you forward, and then every time you hit back, it would just navigate you forward again. So this proposal is, if the user didn't actually interact with the page, don't put it in the history. Only put it in the history if the user actually interacts with the page. So when you hit back, you go back to the original page that you were at, instead of having to go through all the intermediary ones. And actually, this is sort of a rationalization of something we already do in a not very good way. We try to notice redirects and take them out of the history. We just do it in this sort of like hacky way, instead of having like a principled underlying decision for like how it works. And you know, the developer experience is better if it's principled. The user experience is better if it's principled. It just works better. So this is sort of more on the rational end. It's not quite perfect. We know that there's some content we break. If you had like a slide deck that auto-navigated forward and then you hit back, you'd go all the way to the beginning of your slide deck. There are legitimate use cases that this would break. We think they're good enough that we'll probably try them and see how they work in practice. So now I want to talk through a specific example where we started super crazy and then ended actually completely rational. And this is the bad user experience of CPU usage by ads. So visibility, intersection observer will solve one large class of CPU usage. But in practice, again, the way the ad ecosystem works is the top-level ad network doesn't even know what the ad content is. It's something some arbitrary ad agency made. And the ad agency like is not web developers per se. Often it's like designers who don't necessarily think about performance. Some of them. I'm not trying to criticize designers in general. But it's not what they get paid for. They get paid for making beautiful ads that attract your attention. So our first idea was super crazy. We're like, all right, we're going to crowdsource performance information from the wild, and then we'll block scripts that we know violate certain performance guidelines. There's so many ways that's crazy. We were actually optimistic about this for a while, and then we thought about like, first, that's really hard to do. First, you have to define what an ad is, and that's super complicated in and of itself, and political even. And then getting performance information from the wild is really difficult. It's, you have to think about different device classes, and you'll test something and it'll work really well for users on fast phones, but on users with slow phones, it'll be a totally different experience. And the developer experience of that is also crazy, right? Is you build a website, it works. You test it on phones, it works. But then your users, some subset of your users actually get a broken page. So this is definitely not rational. We were like, yeah, we can't really ship that. So let's scale it back a little bit. And our next thought was, let's create a special type of frame. It's like an iframe, but different. And we can restrict what it can do. We can put it out of process. And then we can force ads into those frames. This is a little better. We're not actually breaking any content in theory. And we're sort of strictly better as a user experience. And we were sort of optimistic about this for a while, and then we thought about how do you actually do the forcing ads into these framelets? And it turned out to be basically impossible. So ad snippets consist of like a snippet of HTML, some HTML, some JavaScript. And in practice, what you see on web pages is that snippet of HTML gets split up into pieces. The JavaScript is like incorporated into their regular JavaScript code. It's just like, there was no way we were going to do this. So this idea seemed great at first, and then we were sort of like, it's more on the rational side, but then it's not actually realistically implementable. But also, we sat and thought about it. Are we going to really write like a spec that takes the like double-click HTML snippet and specifies that all browsers should take this and inject it into a framelit, and that's like part of the web from now on forever? Not awesome. Then we had this insight of like, wait a second. What if we just took all cross-origin frames and put them in a shared process? You don't get all the benefit of the previous proposal, which is to say top-level script from the ad networks still causes you problems. But you get performance isolation of the script inside the frames, which in many cases is the worst offenders. And in particular, the ones the ad networks can't even control. Whereas now we've simplified our problem, is the content inside cross-origin frames we can preempt if it's being slow. And we don't break anything. It's purely backwards compatible. It's technically not even an intervention anymore, which is like best of both worlds. And dealing with the top-level script is a more scoped problem. There's only so many ad networks in the world. We can go talk to them and be like, your script is slow. We couldn't go talk to all of the people who write ad creatives. That's a very large population. And to give credit here, conveniently, we already had a team building out of process iframes. And they didn't have quite this use case in mind. They were security-minded. And they're still security-minded, and they'll do that eventually. But this is actually a short-term thing they can implement sooner that will have direct user benefit. This 7 to 50% thing is sort of a fake number. We've looked at some data in the wild, and we know that at least something like 7% of janks would be mitigated by this. I have an intuition that it's larger, but we're very early in the data gathering, so the 50% number is total nonsense. I'm just being hopeful and optimistic. So this is like the best case scenario, is you start with something crazy, you think really hard about it, and then you end up with something that's just not crazy at all, and is just a better user experience. So interventions so far, we've shipped a couple. They've been pretty dramatic. This pause rendering of off-screen iframes has had a really large battery savings. There are ads that will render, they convert like Flash ads to HTML, and then the Flash has an animation. And that animation is just running in script, and the ad isn't even visible, and it's just sitting there chewing through your battery. And this definitively solves that problem. It just pauses when it's off screen. We have a couple good ones that are almost ready. I mentioned top document isolation earlier. That was the stick all the things in a stick all the cross-origin iframes in a separate process. And scroll anchoring, I won't go into it now. Steve is going to give a lightning talk about it later. It's super awesome. I run with both of these. I have for a couple months now. I really don't actually notice bugs, but they're not quite ready to ship yet. And then we have a whole bunch that are actually, we're actually working on all of these. It's not just sort of like, we plan to get to these eventually. It's just sort of, they're not at a point where you can try them. They're sort of more in the idea phase. They're at different levels. Some of them are like about to write code. Some of them are, we're still in super crazy idea phase. And in addition to these, we have like another dozen or so that we want to do eventually, but are lower priority. And as we've started this project and gotten more organized about it, we just keep finding more things. It's like, wait, we can fix that. And I'd say we add 1 or 2 things every month or two. And you should come talk to me if you have ideas of things that will have a big user benefit. Even if it's crazy. Again, we start with crazy, and then we figure out something we can actually ship. come help us. The list of what we know about at the moment and are planning on fixing is a spreadsheet at the bit.ly URL. And the GitHub WICG repo is where we discuss these things with other browser vendors and the web community in general. Please join us there. Every new idea that we're like about to start working on, we propose it there first so that we can have the best chance of having all browsers move in lockstep and give a consistent web developer experience. Thank you very much. We can do questions. Stefan, do you want to come back up? Any questions?
If you're doing some of these decisions, like moving the cross-origin iframes into a separate process, do you expect, like, again, workarounds for that so that the sites would start proxying something on the same origin so that you have less ways of determining and filtering in the end?
Yeah, so that's a good question. I think this gets to the rationality question.
Can you repeat the question?
Oh, sorry, the mic didn't work. The question was, with this cross-origin frame thing, do we expect that people will start working around that, and then now we have a new problem? Is that an accurate summary?
Yeah, like proxying the scripts to be the same origin or something.
He said, like proxying scripts to be same origin. There's a couple things. In practice, that'll be very hard for the ad ecosystem to move to same origin. That might happen anyways because of ad blockers. But it's a huge shift for the ecosystem. So in practice, I'm not worried about it. But with this specific intervention, I'm actually not worried about it at all. The ads don't lose anything here. They have no incentive for moving. It is mostly a strictly better experience for everybody. So in this specific case, no, I'm not worried about it. In general, though, that's the kind of thinking that we do anytime we think about one of these interventions. We actually sit and think, like, how are people going to work around this? Are we making the developer experience so bad that they have incentive to work around it? Right? In the video case, it turns out video ads monetize really well, and so it was worth going to extreme lengths of compiling VP9 via Scripton and then building entire industries around doing this. And we could have seen that one coming. In some cases, it's hard. An interesting one is the scroll anchoring one, actually, is, well, I'll say what it is. Steve will demo it later. It's basically, if content loads above the fold, right now, the content you're viewing actually moves down, which is obviously a bad user experience. And we're like, why don't we just keep the content in the same place? Which is to say, we'll scroll the page as if the user scrolled it. So as far as the web page is concerned, the page happened to scroll right when this image loaded. But as far as the user is concerned, nothing happened. I have some concerns there around, there's some cases with people who make in JavaScript fixed position headers or sticky headers that don't work well. In some cases, on TechCrunch, you get in an infinite scroll loop where the page is just scrolling itself like that the whole time. So I'm sort of concerned about that. And our solution to that has been, we're going to give developers an opt-out. We don't need to be draconian about these things for the most part. Most interventions are about making the default good. And if a developer really wants to go do something else, there are legitimate use cases. And we should, for the most part, let them. There's rare exceptions to that. But mostly our solution to developers working around things is let them do it in a first-class way instead of forcing them to do it in some crazy way that makes the user experience bad. But in general, we're very worried about war of attrition style solutions to any of these things.
I think we have time for one more question.
Oh, sorry, I talked too much.
Does it work? Yeah. So you almost answered this one. With Michi's #1 priority for the predictability for the platform, your business becomes tricky. But I can see how, comparing to the last BlinkOn, it kind of steers from more crazy towards more sane, almost an incremental platform improvements on the spec level and working with the vendors. So is it now the sort of incremental work with the vendors and it's just a spec business? Or what is left from the sort of interventions?
Yeah, that's a good question. So I'll try to restate the question. When we talked about this 6 months ago at BlinkOn, we were super in the crazy, like on some pages, under certain conditions, we're only going to do this, because the page is misbehaving. Now we're sort of like, we're actually just making a small change to the web platform. We've done this before. Why is this interventions? In practice, it's not that different than what we used to do. It's sort of more organized and principled, right? Is the connection to there has to be a direct user benefit is sort of different than what we did before. Before, you made different arguments. You'd make arguments about like, oh, it's a better platform. Interventions are very focused on the user experience. But basically, yeah, we're just changing the web. This is not that different than when we make other changes to the web. We work with other browser vendors. Again, there was those rare exceptions that I mentioned of ones that we do only on certain conditions. So ones that we do, we're changing in progress. We haven't shipped this yet, but we're planning on changing scripts inserted via document.write to not run on 2G networks. It's super crazy, but the user benefit is so large that we're like willing to consider it. Do we spec that? Maybe. That stays in the sort of older 6 month ago definition of interventions, where it's sort of like, it's a little crazy. But the difference is like literally a 20-second page load versus like a 3-minute page load if you're on a 2G connection. It's really dramatic. So basically, long story short, yes, most of these things, as much as we can, we want to just do the same thing we've been doing for decades, which is we identify a thing, we change the web platform, all browsers agree to it, we change the spec, it's great. We do that 99 out of 100 times. 1% of the time, we still do the like super crazy thing. And even then, we're super cautious about when and how we do it. This 2G thing is a rare exception.
So,
All right. We'll still be here if people want to chat afterwards. Thank you.
thanks a lot.
All right, thank you guys. So next up is lunch. And gosh, this thing's so confusing. After lunch, we're going to come back. There's a main room talk here about, I believe it's Houdini. But everything should be on the schedule. We actually reformatted it, so it's a lot easier to read now. Huzzah. What was this? Yeah, we'll put it on the screen when we're gone. Question? What's up? Okay. We'll look into mobile, see what's going on there. Anyways, yeah, so next up is lunch. Jochen, are we doing lunch just in the cafe, or?
Just the cafe, yeah.
Just in the cafe? All right, so it's just right across here. Should be pretty easy to find if you get lost. You don't know how to go straight. And we'll see you guys back here after lunch.
Keine Ahnung, wo man das irgendwie ausschalten kann. Das kommt die ganze Zeit. Yo. I think we're now very proficient with the presenter view. Nahrung.